I like this problem, number 2, because it's a little bit different than others that you're used to. So we want to determine the coefficient of friction acting on this toy with, it's got an initial speed that slows it down, and so we've got the normal force pointing up, we've got the weight pointing down, and we have this friction force acting backwards. Although this forward motion is not a force. So actually the first thing we need to do is we need to get the force, or we need to get the acceleration of the toy. So we don't have time, so I'm actually going to use this formula. V squared equals V naught squared plus 2 times A times x minus x naught. So I know the final speed is 0. The initial speed is 5. We'll square that. Plus 2 times A times 10 minus 0. Simplifying further, we're going to end up getting negative 25 equals 20A, which is going to be negative 5 equals 4A, or A is negative 1.25 meters per second squared. Now we know the acceleration. Now let's write down the balanced and unbalanced forces equation. So I've got the normal force balances the weight, which is going to end up being 20 times 10, that's mg, so that's 200 newtons worth of force. And so we know the friction is going to actually equal ma to slow it down. I mean, that's acting to the left. So if you wanted to write like a capital F here and write this as like 0 minus F, since there's no force acting to the right, you could do that as well. So we have 0 minus friction equals m times A, or negative F equals 20 times 1.25. And so when we actually solve that, that's going to end up giving us 25 newtons for the, and that's negative 1.25, so negative 25 newtons for the friction. And so let's get our coefficient of friction. So we have friction is 25 newtons. We also know that friction is mu times n, and we know that the normal force is 20 newtons. So we're going to get 25 equals mu times 20, and when we solve, we're only going to end up actually getting mu is 0.8 as our answer.